In this video, we're going to look at how to solve a simple projectile motion problem. Consider this example. A soccer ball rolls at 3 meters per second and falls off a 10-meter cliff. We're asked to find how far from the base of the cliff did that ball land. The first thing we do is draw a picture stating the obvious information given to us in the problem, such as the initial velocity in the x is 3 meters per second and the displacement in the y was 10 meters down, or negative 10 meters. Now, there's some other information that we need to extract from this. One of which is our acceleration in the x is going to be 0. It's a constant velocity. Nothing's accelerating it in the x direction. The next thing is gravity is making this ball fall down. So we do have acceleration in the y direction. That's our negative 9.81 meters per second squared. And finally, we also know that when a ball is dropped, or when something starts to fall, its initial velocity in the y direction is 0, because it starts at not moving in the y direction and then accelerates down due to gravity. So we write down this information that we have in a nice organized table separated by our x and y directions. I've marked the time in blue just to help remind us that the time it takes to travel that distance in the x direction is the same amount of time that it takes for the ball to fall in the y direction. After all, it's the same ball. Now that we've recorded our information in an organized fashion, it's time to choose a formula. We'll need one for our x direction and one from our y direction. The formula for the x direction is simple. Since we have a constant velocity, meaning no acceleration, there's only one to choose from. That velocity is distance divided by time. When it comes to the y direction, however, we do have a lot of options. One thing that we need to know is our time. So I'm going to underline every formula that includes time. Instantly, this eliminates one of the formulas. The next thing is we don't know the final velocity, and frankly, we don't care. We weren't asked to find it, nor do we need to find it in order to progress through the problem. So any formula that contains a final velocity, I'm going to cross it out. That leaves us with one formula left. The distance is our initial velocity times time, plus 1/2 acceleration times time squared. Now we have all the information that we need to get going with this problem. We add our formulas into the information that we know, and since how we have everything in the y direction to solve for time, we'll solve for that first. Now, we have all the information labeled out here for you. I'd like you to pause the video for a minute and try and solve for time on your own. Once you've found it, resume the video to check your answer. Alright, so to find it, we have all the information we need in the y direction. So we simply take those numbers and plug it into our formula, rearrange algebraically to solve for time, and put it in our calculator to find time is 1.42784 ... seconds. Now we're going to need to keep all those values because we're not quite finished with the problem yet. I'm just going to write down 1.4 into the information that we now know. Now remember, since it's the same ball, the time it takes for it to land in the y direction is the same time that it takes for the ball to land in the x direction. Now that we know that the time is 1.4, etc. seconds, we have everything we need to find the displacement in the x position. I'd like you to pause the video now and try and solve for the final answer yourself, then check back. Okay, so once again we plug in the information we know into our basic formula, rearrange algebraically to solve for the displacement in the x, and finally put it in our calculator to get our final answer of 4.2835, etc. meters to the right. At this point now that we have this, we just need to simplify down to the proper number of significant figures, in this case it's 1, to get our final answer of the ball landing 4 meters away from the cliff. Thanks for watching the video. If it helped out, consider subscribing so you don't miss any other great physics videos. If it didn't help out, or if you thought it was confusing, please leave a comment below. I'd love the feedback so I know how to make better videos next time. Thanks a lot!